All right. Hey, you professional astronomers, get it together.
Sorry.
Can everybody hear me?
Yes.
Yes.
Awesome. Well, hey everybody, welcome to the weekly space hangout for Friday, November 14th, 2014. The Rosetta special.
Yay, Rosetta!
So joining us this week live from the DPS,
The
we've
Division
got
of Planetary Sciences.
We've got Sandy and Morgan in the same room. Check it out. Now, just to show that this isn't like some kind of digital composite that we've done, can you guys like do a high five or something?
There we go.
There it is. Still, we could probably fake it, but still, I'm gonna, trust me, they're actually in the same physical location. And this is the first time you guys have met, right?
Yeah.
It is.
And we
And you-
even have another radar person here, Sean, but he's packing up.
Hi.
And has no idea what he's got himself.
Very disoriented right now. Pretty much.
I'm sure. We got Dr. Brian Koberlein.
Hi.
And not at the DPS, and we've got Ramin Skibba. Hey, Ramin.
Hi. Happy to be here.
Dr. Ramin Skibba. Sorry, I got to keep all these.
Whatever.
Yeah. And both Sandy and Morgan are working on their masters. They're working their way through their doctorates. So yeah, soon you'll be PhDs.
We both have masters.
Yeah, I know, but soon you're working on your PhDs. Soon you will. I can call it to be doctors all around.
Yeah, but you can call them master.
Master
Yeah.
Sandy. So
They may be doctors, but we're masters.
Asteroid blaster.
Right.
Very
That's
impressive.
So I cannot guarantee that we're going to talk about anything other than Rosetta this week. But we do have a bunch of other stories. So why don't you guys kick it off, because you were there live at the DPS as they broadcast a live view. I know everyone got up super early to be able to watch it. So give us the news. What happened? I hear we landed on a comet this week or something?
Yeah, we landed on a comet. So the Rosetta mission, if you've been living in a cave on a comet somewhere, was launched by ESA.
If you've been living in a cave on a comet, look for Philae.
So the
Push it out into the sun.
The spacecraft arrived at this comet, and on Monday night they launched a little lander to go land on the comet. And so this is great. It has a harpoon on board. It's going to land at this carefully selected landing site. It's going to get enough sunlight during the day to charge its batteries, and it launches, and they get photos of it descending down towards the comet. It's this beautiful black and white image with a beautifully overexposed lander, and it lands on the comet, and we're sitting, there's about 100, 200 people in this room at the conference with really crappy conference Wi-Fi watching this landing live, and then the stream pauses because everyone's watching the landing on their laptop too, and everyone's refreshing Twitter and Facebook. And Andrew Steffel from Colorado is refreshing his Twitter feed, and he says, "We've landed. I've started seeing tweets from Emily Lakdawala that we've landed on the comet," and the whole room erupts into cheers, and then there's the live feed done by the ESA folks, and everyone's really happy. Mr. Churyamov's there, Mrs. Gerasimenko's there, the folks who discovered this comet. And, people peter out of the room for the rest of the day, and all of a sudden we start hearing that the harpoon didn't deploy, that the lander has a harpoon on board to stick itself to this comet, because this comet on a good day is it's like a snow cone. It's shaved ice. It's very fluffy. It's not solid. They were expecting to land on a spherical comet. Instead, they land on a rubber ducky, because they didn't find out it was a rubber ducky until after they launched and arrived at this comet. So they realized that this lander bounced not once, but at least twice. And so
also, it's worth mentioning that it's really lucky that it didn't just disappear, because the gravitational force is so weak.
Yeah, that one bounce, it traveled a kilometer over a couple of hours at 30 centimeters per second. That's incredibly low gravity.
Not a lot of fun if you've been, in hibernation for a while, and all of a sudden you land on this comet, and then you bounce, and then you bounce twice. But as we've been joking around here for a while, a bunch of folks from, I think, JPL have been trying to get a comet hopper mission going, where you'd have a little spacecraft that would go hopping along a comet. Well, I guess they have their mission concept validated, and they can move on to other things by now.
So I mean, the good news is they landed on the comet. As you said, it hopped quite a bit. But what is the state of the lander right now? From what I understand, it's not doing that well.
Well, we've heard a couple of rumors. Well, we heard that it landed with one leg up in the air. So if you're seeing photos on Twitter of people doing weird yoga positions with two legs down or one leg down and a leg up, and that's sort of what orientation they think the comet landed in, or the lander landed in on the comet. But there's some insinuation that it may be a little flatter now. But originally it landed by a cliff in a shadow, and it was only getting an hour and a half of sunlight a day when they were expecting it to get 6 to 7 hours of sunlight a day. So it's a bit of a problem if you were a solar-powered lander and you don't want to freeze to death.
Do you know how that affects the experiments? Which ones need that power?
Yeah, so they had enough power to do all of the experiments, and they held off on doing any experiment that required motion initially to make sure they didn't tip themselves over. So they didn't drill, they had some ice screws, things like that. They didn't use those right away. But they did immediately start collecting data while they worked to see what had gone wrong, basically, and whether they could fix themselves. And they had a battery that was supposedly good for 50 hours of work. And that was there basically so that they could do things while they figured out where they were initially. And it became basically the lifeboat battery for the mission. So they started just doing as much science as they could, because if they took too long to make decisions, the battery would run out. And so they completed 80% of their initial science objectives in the first 24 hours or so. And then with the last battery, started using the drills and other motion instruments to try to understand better the interior of the comet. And they're hoping that with those functioning, they'll be able to get 90% of the initial data that they were hoping to collect on the comet, even though it didn't go quite as planned.
That's great news.
Yeah, the bigger problem is that if the battery dies with the data on board the lander, we're going to have to wait potentially a very long time to get that data back, because there's only so much you can do to radio the data from Philae to Rosetta and then Rosetta to Earth. And Rosetta can only hold so much, and the speed is relatively slow in comparison to what we might be used to. And so there's a good chance that a lot of this last data will be stuck on the internal hard drives of Philae until it can hopefully boot itself up again in about 8 months.
That's crazy.
Maybe it'll freeze to death.
Right.
Poor little filet mignon.
Oh, so I got a couple of questions here from our viewers. One comes from Noel Ruppenthal. Now, would it be possible to reorient the lander using the Kerbal Space Program technique of retracting your landing gear and redeploying them? And let me tell you, I have used that technique in the Kerbal Space Program many times, and it has saved me. So now this is not that crazy, right? They're thinking of deploying something like this to try and move it around.
Yeah, well, they considered this, and the first decision they made was that it's important to get as much science as they could before they did anything else. Because, you know, as you've probably experienced in Kerbal Space Program, half the time you do this, you're just going to fall over. Or you're going to fly off into an even less desirable spot on the comet. So they wanted to do as much as they could, and that's really panned out for them, is that they've done 80% of what they intended to do with this lander, even given all of these problems. And so now, with the dying gasps of the battery, they can sort of fling out and with the harpoons and things and try to move themselves. But I don't know if they've decided whether or not yet to do that.
So, question from Yov Landsman. Do you know what is the height of the cliff that's casting the shadow on Philae? So, do they know how big this cliff is that's blocking it?
No. They know it's big enough to block their view, but other than that, they don't know how big it is, because Rosetta can't find the lander on the surface. So they're scanning with the high-resolution camera to see where it could be and trying to find the location of it so they can better understand the situation they're in. But it's so small. We're talking about a washing machine-sized object that's basically in mountains the size of a small city. And they just can't spot it, especially if it's in deep shadow. And so they don't really know much about the location around it.
All right, so time to get a little controversial now. So Nathaniel Sanchez says, hey everyone, I've heard that some of the high-resolution color images of 67p were shown at DPS. Did you guys get a glimpse?
Yes, we did, and they were amazing.
They're pretty cool. There are a lot of folks oohing and awing and in the hallways and on displays.
That was the talk of Monday.
Okay, so let's give people some context here. So I don't know if everybody who's watching this is aware, but all of the pictures that we're seeing of 67p from the Rosetta mission are only coming from the nav cams on the mission, and that the best pictures, the high resolution color images, are actually being, I don't know what, censored, held back, not permitted to be seen by anyone except for the scientists that are working on this. And the rationale for this, of course, is that the scientists need first crack at the images so they can produce their scientific papers. I think that's nonsense, and I think that these images should be released live. Fine, do your science, but
so all I can tell you is for OSIRIS-REx, we are going to be releasing the images as soon as we get them to the public, but we are not ESA, and Dante Loretta really believes in having everything, all the images, all the data out there as much as possible. And
so is ESA worried about being scooped or something? I mean, that would be a weird, that would be a really...
ESA works differently than NASA, and that's part of the problem, if you want to call this a problem. NASA has control over all the instruments on the spacecraft, and they have ultimate say about what happens and what doesn't happen on their missions. ESA is like the European Union. It's a consortium of individual science programs from the different countries, and each country is allowed to set its own rules and regulations regarding the data and operation of its instrument. And so in this case, the science camera, OSIRIS, has chosen to not release their images until after what's called the proprietary period is over, and that's usually about a 6-month period in which the scientists who design the observations, which is a lot of work and a lot of effort, get sole use over those images to do their science. And ESA headquarters can't do anything to make them change their mind, basically, which is why we're only getting these navigational camera images, because ESA headquarters owns the NavCam, and they want these images out there for public relations reasons, but they can't basically have any sway over the individual member countries of ESA.
Can I make a Socialist Europe joke here? No, I won't.
Well, I think from a public relations standpoint, it's a disaster. So, the quality of the images that are being released is right now pretty mediocre. I mean, it's amazing what's in them, but the actual quality of them is pretty low. And to know that the better images are out there and that they're not being released is pretty frustrating. And I know that down the road, when they finally release the big images, people aren't going to really care. Like, oh yeah, those are pretty images. But right now, everything's in the public eye. These images would be doing an enormous boost to space exploration, to science, to helping get the word out there. So I really think it's a pretty short-sighted decision by
and this is how NASA used to do it. And the two missions that have really turned this around were Cassini at Saturn and the Mars Science Laboratory, Curiosity on Mars. And those two are basically churning the images out as fast as possible. And it's really set a new precedent for how the public interacts with scientists on these big missions. And I think it's really only had positive effects. I'm not aware of any accusations of scientists being scooped by other scientists.
There are some people on Cassini who are upset that amateurs, unfunded experts do reprocess images, and I think that's also short-sighted, and I think that doesn't. If folks want to reprocess images, if people want to do science or just pretty pictures on images that have come down from the spacecraft, they should be able to.
Mm-hmm.
So the Herschel and Planck telescopes, which I think are both European, they did have a proprietary period, but they also required a lot of work to process the data before being able to reduce any images.
Right.
In this case, I think, as you're saying, Fraser, these images would be incredibly popular, would be great for public relations, and it's, I don't know, I think people would look, if someone were to try to scoop them, I'm sure they would be like blacklisted or something. It wouldn't look good.
Yeah, that's what Emily Lakdawala was saying. That she couldn't imagine that Nature or Science or any of these journals would publish a paper with accusations of scooping the mission scientists.
Okay, so we got another question here from M23W23G. Has there been any effect on the comet's trajectory by Rosetta's orbit or the probe's multiple impacts? So, is there any? Could that tiny probe make any change on 67P's trajectory? No.
You would not be able to measure it at all.
So the gravity is the mass of Philae here on Earth is 100 kilograms. So not only does it look like a washing machine in size, it weighs about the same as a washing machine. But on the comet, its mass is 1 gram. And we're talking about a hunk of rock that is...
Its mass or its
weight? I'm sorry,
okay.
Its weight is 1 gram.
Wait,
and
units.
1 gram.
Okay.
We're talking about a rock that's basically the size of a small city. You can imagine throwing even a washing machine against a city-sized rock. You're not going to move it.
Ilad Avron says, doesn't Philae have some sort of beacon that we can detect, or are we relying only on readings from Rosetta?
It's going to be so weak that you wouldn't be able to pick it up from anything except for Rosetta. And also, I mean, so in order to find where it is, you need to, coming from the radar business, you need to scan this way, you need to scan up, you need to scan down, you need to home in on that. And that is much easier to do in real time if you had, I don't know if Rosetta actually has routines on the spacecraft to do this. So watching this happen at Arecibo in real time this summer with IC3, it's hard.
Right. Okay. So then, what's coming up then? What should we expect in the next couple of days, weeks? Between now and the next Space Hangout.
Well, now Rosetta goes to work. So even if Philae had completely failed, and it absolutely did not, the bulk of the Rosetta mission is the orbiter itself, which has 11 instruments on board, and will spend the next year and a half studying the comet. And they will continue to use the images they take to look to see if they can find Philae. But once the battery is gone, it's pretty much gone. And then we basically get on with the rest of the mission, which will be observing the comet from afar with Rosetta and beginning to analyze the information we got from Philae, which is going to tell us a lot about the environment right at the surface of a comet, which is a place that we've really never been before.
All right, well, fantastic news. Obviously, we've all been super excited about this, and it's awesome that you guys were there and surrounded by other planetary scientists to appreciate the news. They couldn't have timed this any better than for you guys to sort of be in the middle of your tribe as this was happening. It must have been quite an amazing experience, yeah. Okay, cool. So let's... there actually is a few other stories, so why don't we move on to them? So one, Brian, you've got information on the Planck sky surveys.
Yeah, this was in Astronomy and Astrophysics at the very end of October. The Planck team released 31 papers that includes 9 sky surveys at different wavelengths, and a whole ton of data and everything. So there's this huge stockpile of new research now. And the sky surveys are one of the big things, because normally we've seen the image of the cosmic microwave background, and we all kind of know what it looks like. But in this case, they've got 9 different versions. They're all at different wavelengths. And this is important because if we're going to look at things like cosmic inflation and the Bicep 2 controversy, we have to know what's close and what's truly in the cosmic microwave background. And so by looking at multiple wavelengths, we can see what the kind of foreground material actually is. So it ranges from about a centimeter wavelength to about 300 microns. And so from that you can see where the dust is, you can see where the radio signals are from the Milky Way, and know the foreground images really well. So this is kind of a big step forward in terms of looking for cosmic inflation.
And does it change the age of the universe at all?
I haven't seen anything in the papers that says that.
So still
this is really just a matter of making sure we know what the foreground is versus what the background is.
And so this is going to help determine if the Bicep 2 results are correct?
Right. So one of the things that did come out was there was a thing with the asymmetry in the cosmic microwave background, that it may not be the same exact kind of average, the same in all directions. And this has been a little bit controversial, but apparently the asymmetry is still there in the data.
So that's exciting, because people hadn't expected that to.
Right, we expected it to wash out.
Yeah.
And it didn't. So
inflation may still be true. All right, let's move on. So All right, so this one's pretty strange, and Ramin, you're gonna have to walk us through this one. So, black holes are made of dark matter? What?
Yeah, it's a really so it's a strange title and a strange article, but so dark matter, we think that most of the matter in the universe is dark matter, and that when these form, dark matter, clumps of dark matter come together at the same time. So from the force of gravity, in slightly overdense environments, you have dark matter particles that come together. They clump together and they form what we call halos. Now, in these clumps of dark matter, we also have even denser galaxies that form. So that's because gas particles of gas clump together in the same areas. So every galaxy, with a few exceptions, has dark matter, and so but the dark matter extends far out. Now we think that because of the less dense nature of dark matter, there's not going to be that much at the center of the galaxy. But some people say, in this one article in Physics Review Letters, that maybe there's not just regular dark matter, but some sort of antimatter dark matter. I don't know exactly what they call it. And so I guess the combination of this matter and antimatter versions may explain somehow the apparent lack of pulsars, which are rapidly or dense rotating stars in the center of the galaxy. My personal opinion is that this seems like a pretty, I don't know, exotic solution, maybe a little bit too out there for them not finding as many pulsars as they expect. And in fact, the authors themselves say that, of course, it would be exciting to find evidence of this, but they want to be convinced that no standard explanation is actually viable. So it's an interesting story. It's in Scientific American where I saw it written up, but I personally don't believe the result. I think they'll more likely we'll find a more standard explanation for these pulsars.
All right, that does seem a little I don't know. Oh no! Pardon me, it's my fault. I did broke my one rule. Hide all phones.
Now I'm making sure mine is off.
We're broadcasting through my phone.
Mine schedule's off, so.
All right, thank you very much. Okay, so you know what, DPS folks, let's hear more about what was happening. What other new wonders of the solar system did you discover?
So my fairy god astronomer, Andy Rivkin, who's awesome, he's been working with Eric Asfog and Bill Botke, his old grad school buddies, on why we don't see a dynamical member of Ceres. So when you look at the large asteroids, the asteroids that are over 250 kilometers, most of them have a certain spectral signature. And you see that in smaller asteroids out there that are in about the same place as these bigger asteroids. So we see a dynamical family for Vesta. We see a dynamical family for all these big asteroids, but we don't see one for Ceres. Ceres is the biggest asteroid. So chances are something's hit it. And the math shows that something's probably hit it at least twice, something at least 50 kilometers in size. And so we'd expect parts of Ceres to break off. So why don't we see anything that looks like a part of Ceres? So the idea is that since Ceres is sort of this icy world, it might have an icy mantle. So if something's hit it and sort of excavated under the mantle, it would dig up really icy things. And so when those icy things get out there in the asteroid belt, they can sublime, and they would just evaporate over the time scale between when Ceres formed, when it was hit, and now. So if there are Ceres dynamical families, they've evaporated. The family members, they've either evaporated or they've lost so much of their volatiles that they just don't look like Ceres anymore, and we can't connect them to Ceres. So Ceres may have had a family once upon a time, but it's just now gone.
We should send a spacecraft to Ceres to analyze it.
Oh, wait, it's getting there July?
Something like that.
Yeah, sometime next year. Sweet.
Yeah.
Good time.
And the other cool thing that was happening in this session is that Brother Guy Consolmagno of the Vatican Observatory, yes, the Vatican Observatory has an astronomer. He went to school here in Tucson. He's fabulous. He's been studying meteorites for a while, since meteorites are a very easy thing to study. And he's looked at the formation models for getting meteorites from Vesta, these Howardite meteorites. And he's looked at the formation models that the Dawn Science team has come up with, and you can't resolve them. You can't fit them back together. So you can't produce these meteorites that we see from Vesta, these Howardites, if you form Vesta the way that the Dawn team thinks they did, and vice versa. So he proposes, working also with some other folks who do formation and big impact models of things hitting asteroids, is that something hit Vesta early on in its history, and a lot of Vesta vaporized, and that it lost a lot of its mantle. And so that mantle would become the Howardites that have now hit Earth as meteorites, and that the rest of Vesta came back together. And so that would explain the Dawn data and the Dawn formation models, as well as the Howardite formation theory.
And then you also learned something new about Uranus.
Yeah, Uranus, this is Morgan.
Yeah, so we often think of Uranus as like a pretty boring place. It's one of the most featureless looking bodies in the solar system. You know, you look at the cloud tops of Jupiter or Saturn or even Neptune, you often see belts or storms or spots and things like that moving around. With Uranus, we almost never see that. And suddenly, in just the last few years, last few months, we're seeing this huge new explosion of storms. And at one point, they did observing for 2 days. They found 8 new storms on the surface, the cloud tops of Uranus. And these storms are as large as the Earth in size. And at least one of them is the brightest storm that's ever been recorded on Uranus. And this is unusual because astronomers had previously expected that these storms would have peaked back in 2007. That's when Uranus was going through equinox, and this would basically stir up the atmosphere the most. You have the most light from the sun coming in, heating up the atmosphere, causing storms just like hurricanes. And now that it's moving away from that, we'd expect that the storms would begin to subside. But instead, what we're seeing is this new explosion of storms that nobody predicted, and that really so far nobody's come up with a good explanation for.
Well, and as Emily Lakdawala always says, we really need to send a spacecraft to Uranus, if for no reason other than to get the media to say things like sending a probe to Uranus.
You know, we need to stop with that joke, because that joke has just been done so many times. If we're going to be making Uranian probe jokes, they actually have to be more funny and more creative. Because, God, I mean, come on, we can do better. We're rocket scientists.
That's just a price you've got to be willing to pay, Sandy.
You know what? I want the Crohn's and Colitis
Spacecraft.
Foundation of America. I want the prostate cancer, societies. I want all of them helping fund and publicize a mission to Uranus. I am all for uranium. But I'm also for better Uranian jokes.
Well, they'll come. Better Uranian jokes will be invented once the probe has been launched.
On the Futurama show, they changed the name to Eurectum.
Right. Much better name. Okay, we got a few more questions here. So Sev Despani says, do you think they could learn from what happened with Philae and build a comet hopper next time to explore more of the comet? When you say 1 gram, it wouldn't require very much force at all for it to push off and explore a new part of the comet.
Right. So in order to use the harpoon at all, they had a rocket on the other end. Because as soon as this is a basic introductory physics problem. You're standing on like an ice skating rink, and you take your shoe off and you throw it. What happens? You go in the other direction. The same thing would happen with Philae or a similar probe. You shoot the harpoons off in one direction, you're going to go in the other direction. And so they had a rocket that was supposed to fire and keep it basically pushed against the surface. And that rocket also didn't fire. So they encountered a number of challenges. But I think one of the things that we're really learning from Rosetta and from Philae is just how crazy comets are. And the idea that you could hop around a comet sounds really clever when you're talking about a bowling ball-shaped comet. But when your comet is a rubber ducky, and your hops are going to vary in size from a few meters to a few kilometers, predicting and controlling those sorts of hops seems like it's going to be a very challenging thing to overcome. And
It kind of reminds me, seeing the terrain, it sort of reminds me of, like, if you've ever been to Hawaii, the big island of Hawaii, and you've got that lava, you know, and it's just like it's jagged and it's jumbled up and there's no smoothness to it at all. Trying to maneuver around that kind of landscape. I mean, you see these cliffs and the jagged landscape around the lander. I mean, it's so dangerous.
Yeah. So one other story coming out of DPS that didn't get a lot of press, but I thought was quite interesting, is that we got some new results from the Laddie mission. And you might remember Laddie launched late last year or early this year, I can't even remember when, and for a 6-month mission, and it recently crashed into the surface on purpose of the moon to end its mission. And its whole job was to study the dust environment around the moon. And one of the things that it found was that as it flew over the moon, every few minutes it would pass through this big burst of dust. And they couldn't figure out what they were looking at until they realized that even many kilometers up, they were flying through the ejecta of all of the little impacts that happen to the moon all the time. And we knew that these impacts were happening because we can measure them indirectly in other ways, but this was sort of one of these first visceral feelings of, you know, they were basically flying through an anti-aircraft fire kind of feeling as they went through, boom, fly through some dust, boom, fly through some dust. And they're doing this every single hour of their entire 6-month mission, and that it really sort of hammers home how much stuff is out there in space raining down on all of these different worlds.
Anything else while you guys were there that got you sort of pretty intrigued?
Well, so I thought it was interesting that a lot of people here in the Division for Planetary Sciences are gearing up to use the James Webb Space Telescope. And James Webb is not going to be science operational for another 5 years. But people are already starting to ask questions, well, what do we need to do in order to make the best use of James Webb? What is James Webb going to allow us to do that we can't do today with Hubble or other orbital space telescopes? And they're really, you know, anticipating. We think of James Webb as out there to look for the first galaxies and the first stars and evidence of dark matter. But really, it's going to be just as useful for planetary scientists as it is for all of the astronomers out there in the world.
Yeah, I mean, we saw last week with that the new work from ALMA, you know, that new planetary disk that came out. This next class of telescopes, when you look at, we've got the James Webb, we've got ALMA, which I guess is sort of the first super telescope coming online. We've got the Magellan telescope, the 30-meter telescope. There's a whole new class of these telescopes that are, each one is going to be just pushing back the limits so much further. It's a good time to be a space scientist, to have these tools at your disposal.
Unless you're at Arecibo Observatory and the National Science Foundation is saying at agency night at your meeting that they would love nothing more than to divest from your facility and quote-unquote turn the keys over to someone else. If you know of anyone who has $10 million a year that they'd like to send towards running an observatory, please let me know. I'd be happy to talk to them, give them a cat or two in exchange. But it's a great facility.
Is that what it would take to take over Arecibo?
What? $10 million?
Is that what it would take to take over? Yeah?
Nothing.
Yeah. You get free cats, too.
All the cats you can
and
handle, all the
frogs you can listen to at night. But it's been a really it's been a real downer since Monday night at this meeting, since agency night, when hearing from the NSF that they don't they would like to divest of Arecibo, and it'll be recompeted in 2016. But who knows if it's even gonna go on past then. And we had a session Thursday afternoon, and I was chairing a session, and it was 6 talks of radar results from Arecibo, and it was really, you know, just really amazing to see the variety of data and the results we've gotten on near-Earth asteroids. My shape model is in my purse over there, but to know that this facility might not be around in a couple of years is really depressing.
Yeah. Now, did they talk at all about Canada is always glad to take over your failing observatories and spacecraft. Just one always reminder, you know,
okay.
When you guys ditch Cassini, yeah, we'll take over. Second, so the one big news that's coming up shortly is that, and we're going to go through this whole process 2 more times next year, as you said. We've got we've got Dawn arriving at Ceres in July, and then we've got New Horizons arriving at Pluto next year. And so what? In about a month or so, they're going to wake up New Horizons.
Yeah, this was the big moment that Rosetta had to go through, 6 or 8 months ago, and it's a scary time because your spacecraft has been minding its own business now for a long period of time, not checking in with home, and we assume everything is still working, but we don't know. And so it's just this kind of moment of tension while you wait to see, did everything power up? Did anything go wrong during this silent time? Because if it doesn't power up and it doesn't phone home, there's nothing you can do. That's the biggest problem, is if it doesn't wake up and point its antenna back towards Earth, even a giant telescope like Arecibo isn't going to save you because it's not listening, and that's the scary part.
Call me maybe.
Well, here's a good question. We're going to go, 1997, Jan Khrushchev asks, what insights have they made regarding the tech on the orbiter since it took off 10 years ago? I think it's important for people to understand. This is back to Rosetta. It's been flying for 10 years.
Flying for 10 years, and the technology that launched with it is, probably at least 15, 20 years old, because you don't want to launch anything into space that hasn't been rigorously tested. We know some space agencies who do that. We're not going to name names. So you want to make sure everything works, and so it's helpful if it's flown into space before. You can test it rigorously in the lab. So a lot of this stuff, think about the hard drives that were around 10, 15, 20 years ago. Think about anything like that. Stuff for drilling. There's been huge advances in drilling onto planetary surfaces lately. Chris Sackney of Honeybee Robotics is on that. Just anything from your computer stuff, your software, to radiation hardening, to even testing routines. A lot has happened since then.
And there's only so much that they can communicate and upgrade on the spacecraft from afar, and how much is just hardware that they can't improve.
Yeah.
Right. You launch with the mission software that you need to complete the mission, and if you can do better than that, then great. But most of the time, what you have when you launch is what you have when you arrive. And in this case, for Rosetta, it's worked flawlessly. Everything about Rosetta is good. Now, Philae has run into a few caveats, a few issues, other than the fact that it's now stuck in a shadow. But overall, every space mission has its glitches, and Rosetta's glitches have not been showstoppers, and that's pretty much the best you can hope for in a lot of situations.
A few people have been asking me if they could have been more successful with more gyros, more reaction wheels, because as we've said,
the biggest problem
that is always the problem.
The biggest problem was they didn't have a way to slow down. The rocket didn't fire to push them into the comet, and the harpoons didn't fire to hold them onto the comet. So no matter how well they were stabilized, their momentum was still going to hit them into the comet and bounce them back off. And we just got unlucky that both of the methods designed to help keep the comet and the lander together failed at the same time, and that's just unlucky.
Nathaniel Sanchez says the next one should definitely have a pogo stick module.
Oh yeah, for sure.
Yeah. And Bahudders says, sort of go back to Philae, the dust on the comet must be totally different to moon dust. Any guess what it is, rocky nature or something else? So, it's still too early for that science for Philae to actually be tasting the comet, but what do they think it's going to be like?
Ice. It's a muddy snowball. It's got lots of volatiles, it's got ice, it may have methane. If you've taken an organic chemistry class, all of those little short chain things of carbon, nitrogen, oxygen, and hydrogen, yes, they are there on that comet.
This is why we needed to land, and this stuff is working. You don't need to be in the light to go in and measure the sizes of dust and the composition of the dust and things like that. So all of that will hopefully come back to us from Philae, even in its position of darkness. And we'll better understand that. Just the fact that it bounced the way it did will tell us something about the composition of the surface, how rigid it must be to have allowed it to bounce as high as it did. We knew it bounced a kilometer one time and much shorter a second time, and by knowing exactly how that happened, we'll be able to figure out just how firm was the ground, because it seems like maybe it was firmer than we were anticipating, and that's useful information right there.
Does that mean that there's more dust than ice, or just that it's more dense than maybe they expected?
Yeah, it could be less rubble pile and more compaction than necessarily they previously imagined. But I think the bottom line is right now it's too early to know exactly what the results are going to be.
Yeah, I think it'd be really exciting if they're able to do that experiment where they find what kind of organic molecules and amino acids are there, and look at their chirality, which way they're spinning. I mean, it'd be really cool if they find amino acids that are different than the ones that we have that we're familiar with.
Yeah, comets are just these kind of like little time capsules that we're able to understand things that otherwise we'd really have no shot at. And so anything we can learn from them is something we didn't know before. And that's really the takeaway here, is that Philae, Rosetta is succeeding, and we have to be really happy for that.
Let's see if I got any more questions. All right. So Adam Synergy asks, was there any talk at DPS about Sedna and the recently discovered 2012 VP-113 being part of a population of inner Oort cloud objects as opposed to Kuiper belt objects? Is that triggering any memories?
I was at an asteroid session or at the International Asteroid Warning Network during that, so I'm sorry.
And I didn't hear anything about that either. They run far more sessions at these things than anybody can go to.
Yeah, there's 3 sessions in parallel usually at once, so if you're paying attention on Twitter, you can sort of be in 3 sessions at once. But Meg Schwam is on Twitter. You should ask her about the latest results. Excuse me.
Yeah, no, that's my experience as well with these, is that you really have to pick and choose the stuff that you want to attend and the stuff that you don't want to attend.
My first project in grad school was Pluto, so it's like, oh, there's all this Pluto stuff. I know all these Pluto people. And I have asteroid stuff now. But I did go to, there was a wonderful plenary talk yesterday about asteroid Chariklo and its rings. And Morgan here is a rings guy, so it was really fun to be at that session and see about the discovery and how they convinced themselves.
I was freaking out inside and outside during this whole stuff. If you don't know about Chariklo, it's an asteroid about 300 kilometers across, and it has a ring system, and not just one ring, but multiple rings.
Yeah.
And we discovered it basically by accident just a year or so ago, and now we're studying. We basically suddenly we have a whole new ring system. We thought we had rings around Jupiter, Saturn, Uranus, Neptune, but now we have Chariklo as well. And could there be little moons that are helping to shape these rings? We're kind of really just in the beginning of understanding this, but if this is true, there could be a whole population of asteroids out there that have rings on them, and we've just never seen them before.
All right. And in fact, last week they discovered a whole new. Did they announce it? They discovered a whole new star system with another asteroid belt and its own Kuiper belt, and they're able to see both of these in the planetary system. I don't know if they.
Yeah, I didn't see anything about that. That one. You have to these things like 6 months in advance.
Yeah. So Vishalinda Pandy asks, what are the disaster scenarios which are tested before launching the probe, especially when you've not launched any probe that has successfully latched onto a comet? What are the options if everything doesn't go according to plan? So that's, I guess,
Yeah, when you propose a mission, you have to basically show the due diligence that you tried to do everything you could do to show that it would be worth spending the money on. But nothing works guaranteed. And so the proposal for Rosetta said, if this asteroid is perfectly round, and of course we know that's not at all true, we have a 75% chance of landing Philae on the surface on a perfectly round asteroid with everything working properly. And so one of the interesting conversations I think that I've heard several times over the last few days is the difference in how NASA and ESA work. Not just administratively in the sense of their member states, but NASA is so much more risk averse than any other body out there that they might not have even tried a mission like this. And it's not to say that one is better than the other. NASA launches a lot of missions that do spectacular work, and they can do that because their missions work. But ESA had, an opportunity here to do something that, a lot of people thought was just absolutely crazy, and yet they basically stuck the landing. Wow, no pun intended there. And
9.9.
And so, people were saying that, once they found out that the lander was in a shadow, NASA very well would have just pulled back and thought and thought and thought and thought about what to do. And ESA is just like, well, let's try this and let's try that. And it's two very different institutional approaches, both of which have their positives and their negatives. And you certainly see the kind of freewheeling aspect of ESA on display here, and it's really given us some amazing things.
So I think we're sort of reaching the end of the hour. So I want to apologize to all the good folks from the Weekly Space Hangout crew. You submitted a whole pile of great stories this week. And
there was a comet, and we landed on it, and we had a harpoon.
Yeah, I know. Yeah, we landed on a comet.
Little worlds
and
need love, too.
Yeah, so I just want to do a big shout out to the Weekly Space Hangout crew. This is the community on Google Plus that gathers together to talk about the stories, the big space stories of the week. They talk about the stuff we've that's happened here on the Weekly Space Hangout, and it is one of the best communities you can go to on Google Plus, as well as the space community. Cool. So what's the plan now? Sandy, Morgan, are you guys heading out today from DPS?
I have to go home. I don't want to, but I have to go home, back to the real world.
This meeting isn't ending for me. Some of my colleagues are still giving talks, and at like 5 o'clock this afternoon, then I have to go make cheesecakes for this event that's drawing 300 planetary scientists tomorrow night called Bratfest. So I have to go problem set at some point, and like do laundry and.
Right. Well, you don't have to go as far, I think, as Morgan does to get home.
No.
Yeah. So where can people find out more then, Morgan and Sandy? We'll start with Morgan. Where do they find out more?
Yeah, well, you can follow me on Twitter at Morgan Rehnberg, and you'll find a blow-by-blow of the coolest sessions from this year's DPS. You can find me on my website, cosmicchatter.org. And if you post questions to the Google Space Hangout, I may be able to answer some of them while sitting in the airport today. We'll see if the Wi-Fi works. So no promises there, but if you throw some out there, I'll try to make a mother post, and I'll see if I can get any answers out.
All right, I'm Sandy on Twitter. We don't have a lower third since we're doing this from my phone today, but SONDY. Sometimes I post things on sandy.com. And I'll be at Bratfest on Saturday for those of you who are coming to Bratfest.
And if someone wants to take your problem set, if someone wants to study with you, where should they go?
They should. I can email it to them, and it's an Adam Showman special on planetary global tectonics, relevant to icy moons.
I totally want to fill that one out. Brian Koberlein, where do we find out more?
You can find me on Twitter at Brian Koberlein, and you can find me on my website, One Universe at a Time, which is at briankoberlein.com.
And let's say that we wanted to reach into our pocketbooks and support you financially to ensure that more space news comes out. What can we do?
You can find it on Patreon. So the blog is on Patreon.
Patreon.com/Brian Koberlein?
That's right.
Right on. And you also did a guest blog over at Starts With a Bang this week, right?
Yes, I did. Yeah, so if you go to Starts With a Bang, you can see one on science fiction, and basically I crush people's dreams. But
I love yeah. Brian did a great story this week on it's called "Wishing Doesn't Make It True," I think, and it just is like hoverboards, faster than light travel, transporters. Don't hope too hard that these technologies are going to come.
Why do you hate dreams, Brian?
Why do you crush them?
I'm an evil scientist.
Yeah.
Speaking of dreams, there's some conspiracy theories even about the comet landing.
Yeah, I've heard this as well. But
I think if we faked it, we would have faked it better.
We would have faked it with better images instantaneously from the Osiris instrument.
Yeah. So, Ramin, where do we find out more?
So you can find me on Twitter at Ramin Skibba. I'm also blogging at raminskibba.net, where I write about astronomy news as well as science policy issues. And then at my UC San Diego website, I also have some posts about my work, including dark matter and galaxies and the large-scale structure of the universe. And by the way, Sandy, I'll be in Tucson for a meeting first week of December.
All right.
Some stuff on nearby galaxies.
About finals, but
yeah.
break me.
All right.
Sure.
Awesome. That's what we really do, is we encourage collaboration here with the Weekly Space Hangout. So, well, I'm Fraser Cain. There's my Twitter handle. Of course, you can subscribe wherever you're watching this. Subscribe, and that will let you watch all of the videos that we're doing, as well as a few that have been penned by Dr. Brian Koberlein, but made sillier. So, and of course my website is Universe Today, universetoday.com. So go and check it out. We've got lots of great space coverage coming out all day long. So, all right. Well, thanks everyone for joining us. Thanks to the team. Thanks for bringing this live coverage from DPS. I always really like it when people are on location. It makes things even cooler. And we will see you all next week.
Okay.
I won't be. I'm going to be on a planetary science field trip at Kilbourne Hole and White Sands, looking at analogs to the Moffett landing site for one of the Mars rovers.
Are you sure? That sounds like a really great live on location.
I don't think we have internet in southern New Mexico.
Oh, all right then. Okay. We'll see you guys later.
Yeah.
Yeah.